Hello, today's problem is 258 of the AtCoder beginner contest and task D. Let's start. The problem settings is as follows. Uh, you want to play a video game and the game has n stages and uh, the I stage for each I uh, has an opening movie. It takes I minutes and gameplay takes VI minutes. And for the first time, uh, you have to watch the opening movie for each stage. So it takes AI plus BI minutes to clear the stage. But after the second, uh, it takes BI minutes because you can skip the opening movie. And uh, if you want to play I plus one stage, you have to clear all the stages from the first stage to the ice stage. And the purpose of this uh, problem is to clear X stages in total. And then uh, you have to find out the shortest time to clear X stages in total. Let's think about it with the example. We have this video game, and the first stage has 3 minutes opening game, opening movie, and 5 minutes gameplay. The second is 4 minutes opening movie and 4 minutes gameplay, and so on. And we want to clear X stages, equal 10 stages in total. The first case is the this the uh you want to clear first stages 10 times. It takes 3 plus 10 times 5, which is equal 53. And then the next case is you clear the first stage 5 times, and then clear the second stage 5 times. It takes 52 minutes. And the next case is you want to play fourth stage 10 times, but you can't do that. Uh, Instead of it, you can play fourth stage 7 times, and for each stage other than fourth, you play it once, and this is 32. Uh, and then we check the constraints. The n, which is the number of stages, is at most 10 to the fifth, and it is okay. Uh, uh, you can treat the number, the the number uh, correctly. But the x, which is the times you want to play, you want to clear, is 10 to the ninth. It is so big. So if you treat the number x, you be careful. So let's talk about the solution. First, we think about the best way to choose the stage to play. So here's the example as the previous one, and you may find uh, you want to play the fourth stage as many times as possible. So uh, if x is sufficiently large, uh, the shortest time to play is calculated as follows, like this. So uh, you want to choose the shortest time among gameplay times. So here we have 3, 4, 2, 1. So you want to choose 1. But what if um, movie is so long? So this case, uh, I replace here the previous example is 2, but I replace 2 with 10 to the 10th. In this case, even if the gameplay time of the fourth stage is very, very short, but you may found you shouldn't play the fourth stage because the movie is too long. Uh, you don't watch it. Uh, so the shortest time to compute the shortest time is complicated, but uh, if you suppose you play up to the I stage, uh, if you add the hypothesis, uh, you can find the shortest time. You can easily calculate the shortest time uh, under the assumption. Uh, the shortest time is calculated as follows. So this is the uh, same as here. Which means I the J is special, but the J is the shortest game frame time. Uh, the J's stage has the shortest gameplay time, and then the shortest time, which is uh, what we want, is calculated as follows. So uh, we take the minimal value of among them, the shortest time where you play up to the first stage. So the shortest time under the assumption that is you play up to the first place, and the shortest time where you play up to the second stage, and so on, and the shortest time where you play up to nth stage. If you take the minimal value among them, this is the answer. So let's summarize the algorithm. So first, so fix uh, I is between 1 and n. This means you suppose you play up to the I stage, and you don't play uh, after the I plus I stage, and then calculate the shortest time under the assumption and memorize the value, and then repeat it for each I, and finally take the minimal value among them, and this is the answer. So that's all about the uh, algorithm. So finally, uh, I I would like to tell you how to find the minimal gameplay time for each assumption. So I recommend you use heap queue. It is a data set. That's because if the minimal function for list is too slow, so if you want to calculate the minimal, if you want to find the minimal gameplay time for each I, so we have B1 from B1 to BI. So we have uh, list list B of length I, and it takes I to find the minimal value. So uh, the total time complexity is sigma of I. This is at most 10 to the 10th. So you may have TLE, so it's not good. So using the minimal function for list is not recommended. So instead of it, use the heap queue dataset data structure. Uh, if you don't know about it, see my code, and you can ask me. So that's all about the task D. Thank you for watching.